Hello, on the previous day we have learned about the function of carburetor. That means how air petrol mixture is prepared by the carburetor. Yeah? কিভাবে carburetor air petrol mixture তৈরি করে at different loading condition of the car. Today we will learn about the working principle of 4-stroke cycle petrol engine. Yeah, look at the board please. This is carburetor. This is carburetor. We already know that. And this is choke valve. This is throttle valve. This is nozzle. Yeah, and this is mixing chamber. Here this is mixing chamber. Now the air petrol mixture enters from carburetor through induction manifold to the cylinder. Yeah, this is inlet valve. This is cylinder. This is exhaust valve. And this is the spark plug. Yeah, this is the spark plug, and this is piston, and this is center line of the cylinder. This is piston pin, and this is piston rod. This is crank pin, this is crank, and this is crankshaft. Yeah, so this is cylinder. This is piston, this is piston pin, this is piston pin or Gagan pin or wrist pin. This is connecting rod or piston rod. This is crank pin, this is crank, and this is crankshaft. Yeah. Now the crank rotate from left side to right side, and due to which the piston moves from TDC, that means top dead center, to bottom dead center or inner dead center, and this is outer dead center. Yeah, when piston moves from TDC to BDC, this is called in stroke. This is in stroke. And when piston moves from BDC to TDC, this is called out stroke. Yeah. So air petrol mixture from carburetor enters into cylinder, but air petrol mixture cannot enters into the cylinder because there is no pressure difference inside and outside of the cylinder. Yeah, that means it is at atmospheric pressure, which is, we know that 760 millimeter of Hg. This is P suffix ATM, that means atmospheric pressure, or you may be said 1.01325 bar. Yeah. So as there is no pressure difference between the inside and outside of the cylinder, so air petrol mixture cannot come into the cylinder. So we have to reduce the pressure inside the cylinder, and due to which when we start the engine, electric starting motor, remind it, electric starting motor starts and runs for about 8 seconds. Yeah, through Bendix drive operation, and due to which crankshaft rotate, and as crankshaft rotate, so piston moves from TDC to BDC or BDC to TDC. That means piston reciprocates inside the cylinder. Yeah, when piston moves from TDC to BDC, the pressure inside the cylinder reduces, that means below atmospheric pressure, and now the high pressure air petrol mixture from carburetor. This is carburetor, you know that this is carburetor. Yeah, so from carburetor enters into the cylinder. And now this is high pressure, and inside the cylinder this is low pressure. Yeah, and as air petrol mixture comes from carburetor into cylinder, now the first stroke, this is suction stroke, starts. And look at the figure here. Look at the figure here. This is PV diagram. That means pressure. This is pressure and volume diagram. And when air petrol mixture enters into cylinder, the suction stroke starts, and which is at constant pressure process. That means isoPST or isobaric process. But as the cylinder is very small, so pressure can be increased slightly. Yeah. So piston moves from TDC to BDC and suction starts, and this is suction, that is A21 suction. Yeah, and P equal to C, that means pressure is constant. And when piston reaches at BDC, that means crank rotates from negative x-axis to positive x-axis. Yeah, then suction is completed. That means air petrol mixture enters into cylinder. Yeah, and as the crank rotates from positive x to negative x, that means piston moves from BDC to TDC, and now the air petrol mixture inside the cylinder is compressed by the piston, and so inlet valve closes and outlet valve is opened. But if our exhaust valve is opened, then air petrol mixture from inside comes out to outside. Yeah, so there is no effect. So now the exhaust valve is closed by the eccentricity device. This is eccentricity device. Now closes the exhaust valve. So as inlet valve and exhaust valve remain closed and piston moves from BDC to TDC, so air petrol mixture inside the cylinder is compressed by the piston. So pressure is increased inside the cylinder. Yeah, and isolated system is occurred. Yeah, and as the piston moves from BDC to TDC, the compression occurs at adiabatic process, and this process actually occurs in reversible process. Why this is reversible? When piston moves, that means reciprocate inside the cylinder, there is no friction. Yeah, there is no friction, and the heat supplied here is much greater than the heat exhaust. Yeah, and the air petrol mixture here superconductive. So this is reversible process, and as adiabatic process is occurred in reversible process, so it is called isentropic process. Yeah, so now the air petrol mixture is compressed isentropically. And look at PV diagram. This is isentropic process. Yeah, that means this is reversible adiabatic process. So this is PV to the power gamma equal to C. And when piston moves from BDC to near clearance volume, due to compression of the air petrol mixture, heat is arised. And when this heat is near the injection temperature of petrol, that means at which the petrol burns, then spark plug, this is spark plug, burns the air petrol mixture and combustion starts. And look at the figure. Piston moves from BDC to TDC. That means volume is decreased. But when spark plug burns the air petrol mixture, the flame expands. That means volume is increased. So combustion occurs at constant volume. Yeah. Combustion, this is combustion. 1 to 2, this is compression. And 2 to 3, this is combustion. And combustion occurs at constant volume. Yeah, V equal to C. Yeah, and here IGNS, that means ignition starts, and this is IGNC, this is ignition closed. Yeah, that means when piston reaches at TDC, combustion is completed. And the burnt air fuel mixture is now at the clearance volume. This is clearance volume. Yeah, this is clearance volume. CV, this is clearance volume. Now, crank rotates from positive x-axis to negative x-axis, and now crank rotates from negative x-axis to positive x-axis. That means piston moves from TDC to BDC, and now the flame expands. Also in adiabatic process. Yeah, and this is adiabatic process. Yeah, this is also adiabatic process, and this is expansion. Expansion. Yeah, so when piston moves from BDC to TDC, expansion is completed, and when expansion is occurred, that means the burn gases work is done by the burn gases on the piston. That means here it is also called working stroke or power stroke. Yeah. Now piston reaches at BDC, and the heat energy of petrol is converted into mechanical work done. Yeah, and this is called power stroke. That means the indicated power we get inside the cylinder. Yeah, and now piston is at BDC. Here this is BDC and this is TDC. Yeah, and this is also BDC and this is also TDC. Yeah, and when crank rotates from negative x to positive x, that means piston moves from BDC to TDC, and when heat energy is fully converted into mechanical work, that means there is no petrol. Yeah, that means here inside the cylinder the exhaust gas, and when piston moves from BDC to TDC, exhaust valve is opened, and when exhaust valve is opened, the greater part of the burn gases escapes out due to its own expansion, and that is at constant volume. This is constant volume, and here exhaust first part is completed. Yeah, that is the major part of burn gases escape out from inside cylinder to outside through the exhaust valve. And after some time, that means after millisecond, when piston reaches at most mid point of the cylinder, that means the burn gas inside the cylinder cannot escape out. Okay, now the burn gases is pushed by the piston at constant pressure. Look at the boat. At constant pressure, this is 1 dash, and here 1 dash and 1, this is very close point. Yeah, and piston when it reaches at TDC, that means here, yeah, here the exhaust second part is completed. So when piston is at TDC, then again inlet valve is opened. Yeah, now when piston moves from TDC to BDC, this is suction. BDC near clearance volume, this is compression in adiabatic process. And from clearance volume to TDC, combustion start at constant volume process. When piston TDC to BDC, this is expansion is occurred. And when piston from BDC to TDC, exhaust is occurred. That means 4 stroke: suction, compression, combustion, expansion, and exhaust. So it is called 4-stroke cycle petrol engine. Yeah. And look at the figure. This is the initial point and final point. Meet at one point and show this is called cyclic process. And this cycle is called Otto cycle, on which petrol engine works. Yeah. In this way, 4-stroke cycle petrol engine works. And on Otto cycle, all light vehicle gasoline engine runs. Okay. And on the next day, we learn how diesel cycle occurs on PV diagram basis. Okay. Thank you. Goodbye.